Okay, imagine this for a second. Picture a particle just ghosting right through a solid brick wall. It defies every rule of reality we know, right? Well, this crazy phenomenon is called quantum tunneling, and it's not just real. It's the secret reason why, well, pretty much anything exists at all. It's the universe's very own ghost in the machine.
This quote just nails it. A particle slipping through a barrier that should be impossible to cross. And this isn't some weird theoretical idea that only exists on a chalkboard. Nope, it's the engine that powers the sun. It's the magic trick that stores files on your phone. And it might have even been the spark that kicked off the entire universe. So where do we actually see this impossible thing happen? Well, for starters, just look up. The sun is shining because deep inside its core, hydrogen protons are fusing together. But here's the catch. The sun's core is ridiculously hot, but it's not quite hot enough for those protons to just smash through the force field that pushes them apart. They just don't have enough energy. So what do? They tunnel right through that energy barrier. They take a quantum shortcut that makes fusion possible, and in turn, makes all life on Earth possible. Now, look at the phone that's probably in your hand right now. You know the flash memory that holds all your pictures, your texts, your apps? That works by trapping tiny electrons behind an insulating wall. So how do they get in there in the first place? You got it. They tunnel.
And this is the most mind-blowing part. The Big Bang itself might have been started by quantum tunneling. A tiny, random flicker of energy in the complete vacuum of empty space literally tunneled from a state of nothing into the something that became, well, everything. Our entire universe. Talk about an impossible leap. So how does this rule-breaking phenomenon actually work?
To really get our heads around tunneling, we first have to understand just how bizarre the quantum world is compared to the one we see every day. It's like it plays by a completely different rulebook.
You know, in our world, things are solid, they're predictable. If you roll a ball at a hill and you don't give it enough of a push, it just rolls back down every single time. But in the quantum realm, particles aren't just little balls. They also act like waves. Their location isn't a single point, it's more like a wave of probability. So instead of just hitting that hill and stopping dead, the particle's probability wave can actually leak right through it. The barrier isn't a solid wall, it's more like a statistical challenge.
So here's the key idea. The particle doesn't blast its way through the barrier. It doesn't find some secret tunnel. Because it's also a wave, its location is all about probability. And there is a tiny but very real probability that it can just be found on the other side of the barrier. It's almost as if it just teleported.
Let's walk through it step by step. First, you've got this particle wave, and it comes up to a barrier. Now, as it enters the barrier, the wave doesn't just vanish. It starts to fade away really, really fast. But, and this is everything right here, if the barrier is thin enough, the wave doesn't fade all the way to zero. A tiny little bit of that probability wave leaks all the way to the other side. And just like that, the particle can pop into existence over there, having successfully tunneled through.
Okay, so now we kind of have a feel for the how. Let's get back to the so what. I mean, how important is this weird quantum effect, really? Turns out it's absolutely fundamental to the entire story of our universe.
This timeline really shows you its cosmic resume, from the very first moment of creation, to the first stars lighting up a dark universe, all the way to the steady light from our own sun that we see today. Quantum tunneling was the key that turned the lock. Without it, the universe would just be dark, cold, and completely empty.
Let's just focus on our sun for a second. The number you're looking at right now, it's just insane. That's a 1 with 38 zeros after it. There isn't even a good way to describe how big that number is. But that's how many fusion reactions, every single one a tiny quantum leap, are happening inside our sun every single second.
And what's the result of all those impossible little leaps? This. 380 million billion watts of raw power. That's the energy pouring out of the sun, the light and heat that crosses 93 million miles to get to us. All because of a quantum loophole.
And look, this isn't just some crazy theory we cooked up. The proof for the universe's tunnel beginning is literally written across the entire sky. The tiny little temperature differences in the cosmic microwave background, that's the leftover glow from the Big Bang, they match the predictions of quantum tunneling on a cosmic scale perfectly.
So, tunneling built the entire cosmos. That's the big picture. But this isn't some ancient history lesson. This is happening right now inside the tech you use every single day. It's the ghost in your machine.
I mean, look at this list. The SSD in your computer, the microscopes that let us literally see single atoms, the little diodes that make 5G work, all of them depend on electrons doing the impossible and tunneling through barriers. It's even happening inside our own bodies.
Enzymes use it to make life-giving reactions happen way faster. So let's make this super concrete. Let's take that phone again. How does the flash memory inside it actually use this quantum ghost to save a picture of your dog?
It's actually genius in its simplicity. To write a piece of data, a voltage gives electrons a little nudge, and they tunnel through a super thin insulating wall and get trapped on the other side. Those trapped electrons, that's a digital 1. Then you turn the voltage off and they're stuck. To erase the data, you just apply a reverse voltage and they tunnel right back out, turning the cell back into a 0. Every single time you save a file, you are commanding billions of electrons to take this little quantum leap.
We've seen that tunneling is essential. It's in the cosmos, it's in our tech, but what does the fact that it even exists tell us about the very nature of reality? And, where could it take us next?
This is such a huge shift in how we see things. For centuries, science pictured this perfect clockwork universe, where everything was predictable if you just knew enough. Quantum tunneling blows that idea up. It shows us that at the very bottom, reality is governed by chance, by probability. Our universe exists not because it had to, but because a spectacularly unlikely event just happened to happen. We won a cosmic dice roll.
And that idea opens up some wild possibilities. Scientists are looking into whether tunneling could explain huge mysteries, like dark energy, or if it means there's a multiverse of other universes that just failed that cosmic dice roll. And of course, it's at the heart of the next wave of tech, like quantum computers and the massive quest to build clean fusion energy right here on Earth.
So we'll end on this thought. The very fabric of our reality is woven together with an effect that just plain breaks our common sense. It's an incredible reminder that the universe is so much stranger and so much more amazing than we can even imagine. And it really makes you wonder, if this impossible thing is so fundamental to everything we know, what other impossibilities are still out there, just waiting for us to find them?